Hi everyone! In this video, we're going to go over one of the most important skills in chemistry, which is doing conversions with moles. We'll cover some fundamental topics related to moles, including what is a mole, the mole bridge, mole to mass conversions, mole to particles conversions, and mass to particles conversions. In chemistry, a mole is a number, and it's also called Avogadro's number. Similar to how a pair means 2 and a dozen means 12, a mole means this number, 6.02 times 10 to the 23rd power. To give you a sense of how huge this number is, if you try to count from 1 to 6.02 times 10 to the 23rd, and you counted with a speed of 1 number per second, you would need to count for 1.4 times the age of the universe. Chemists use this large number to count atoms and molecules because they're super tiny. A mole is abbreviated as MOL. That's right. The only thing you take off is the E at the end. Moles are really useful because they let us get something called the molar mass. That means when you have 1 mole of atoms of an element, its mass in grams is the mass number on the periodic table. For example, here's aluminum. If you have 1 atom of aluminum, its mass is 26.98 atomic mass units. If you have 1 mole of aluminum, its mass is 26.98 grams. The nice thing is you don't have to do any conversions. You just change the unit from AMU to grams. The unit for molar mass is grams per mole. Here are some more examples. The molar mass of hydrogen is 1.01 grams per mole. The molar mass of oxygen is 16 grams per mole, and the molar mass of carbon is 12.01 grams per mole. You can also find the molar mass of compounds. That just means you total up the element masses. For example, what is the molar mass of water? Water is H2O, which means it has 2 hydrogens and 1 oxygen. For the molar mass, I'll do 2 times 1.01 plus 16. The molar mass of water is 18.02 grams per mole. Whenever chemists do conversions, we use something called the mole bridge. What that means is lots of things can convert to moles. You can convert between moles and mass, and you can convert between moles and particles. Particles includes atoms, molecules, and formula units. Formula units are units or molecules of ionic compounds. Molecules refers to covalent compounds. This is called a mole bridge because with moles in the middle, you can convert between mass and particles if you go through moles. Let's do some examples. Here's a mole to mass conversion. Keep in mind that mass means grams. If you have 5 moles of CH4, what is the mass? The molar mass of CH4 is given to us, 16.05 grams per mole. When you do conversion problems, always start with the number that is given to you in the question. That's the starting point of your conversion. So I'll write down 5 moles of CH4. Then you multiply by a conversion factor, which is a ratio. I'll set up my fraction bar here for my ratio. The trick to doing conversions is to fill in the units first. There's a pattern. Whatever unit you start with will be in the bottom of the next step. I start with moles of CH4, so that goes on the bottom in the next step. The top is what I'm looking for, which is grams of CH4. Now I can fill in the numbers. Ask yourself, what is the relationship between grams of CH4 and moles? That relationship is the molar mass. 1 mole of CH4 is 16.05 grams. Now I can cancel the moles from the top and bottom. Multiply the numbers on the top and divide by the numbers on the bottom. The answer is 80.25 grams of CH4. Let's do another one. If you have 50 grams of ammonia, how many moles of ammonia do you have? We're given the molar mass again. We'll take the number given to us in the question and write that as the starting point. Then I'll set up my conversion factor. Whatever unit I start with goes to the bottom, so grams of NH3 goes to the bottom. The top is what I'm looking for, which is moles of NH3. The relationship is that 1 mole of NH3 is 17.03 grams. I can cancel the grams, multiply the numbers at the top, and divide by the bottom. My answer is 2.94 moles of NH3. For conversions between moles and mass, you might sometimes see this equation. This is exactly like the question we just did. This means if you want to find moles, you take the mass and divide by the molar mass. Let's do more conversion practice. For this question, if you have 8.03 times 10 to the 24 atoms of sodium, how many moles of sodium do you have? Again, start with the number given to you in the question. Then set up your conversion factor. I start with atoms of sodium, so atoms of sodium goes to the bottom. I'm looking for moles, so moles of sodium goes on top. For the numbers, what is the relationship between moles and atoms? The relationship is that 1 mole equals 6.02 times 10 to the 23rd atoms. Atoms cancels, and my answer is 13.3 moles of sodium. Here's another problem. How many molecules of water are in 2.04 moles of water? I'll start with the number given to me in the question, 2.04 moles of water. I'll set up my conversion factor. Moles of water goes to the bottom. I'm looking for molecules, so molecules of water goes on top. The relationship is that 1 mole equals 6.02 times 10 to the 23rd molecules. Moles of water cancel, and I get 1.23 times 10 to the 24th molecules of water. Let's do a problem that goes from one side of the mole bridge to the other side. How many molecules of water are in 36.04 grams of water? This is going to be a two-step problem. I'll start with the number given to me, 36.04 grams of water. Now, instead of going straight to molecules, I have to use the mole bridge and go to moles first. The units I start with go to the bottom, and moles go on top. 1 mole of water is 18.02 grams. Grams will cancel. Then I go from moles to molecules. This time, moles is my unit on the top, so I'll put that on the bottom. On the top will be molecules of H2O. 1 mole is 6.02 times 10 to the 23rd molecules. Moles will cancel. Finally, I'll multiply across the top and divide by the bottom. This is my answer. We'll just do one last bit before we end this video. What if this problem didn't say molecules of water? What if it said atoms of hydrogen? In that case, we'll just tag on one more step to our problem. Let me move our original conversion to the side. We ended with moles of water, so we can add one more step to our conversion. We can write molecules of water on the bottom and find atoms of hydrogen on the top. The relationship between atoms of hydrogen and molecules of water is that there are 2 hydrogens per molecule of water. Here's my answer. Or there's another way. I'll use the molecules of water that I calculated before. Then I can simply reason that there are 2 hydrogens per water. If I have 1 water molecule, I'll have 2 hydrogens. If I have 2 water molecules, I'll have 4 hydrogens. So I can just multiply the water molecules by 2 to get the number of hydrogens. Mole conversions are super important in chemistry, and they're not complicated. Just remember to follow the mole bridge and you'll get it in no time.